Thanks for the opportunity to speak here tonight. My speech is probably a little bit different to it's looking more at energy and water and not explicitly health. So I work within the Division of Land and Water of CSIRO and in particular in the urban water field. So the project I'd like to talk about briefly is the Water Energy Futures for Melbourne. And this, sorry, just going down to the slide. And this project emerged from the context of increasing urgency for policy development that offered solutions to Melbourne's long-term water security and the need to consider the implications of these different options such as desalination on the energy demand and the greenhouse gas emissions. So the primary purpose of this project was to improve understanding and promote dialogue on the complex interrelationships between water and energy, and to assess and influence relevant policy levers in context with Melbourne's total water and energy throughputs. So we went through a process where we developed 6 scenarios that were analysed to 2045 using a model of the Victorian physical economy, which is called the Victorian Stocks and Flows Framework. So why use a systems approach? So the scenario set that we developed was developed around a range of some of the key drivers that we saw. So looking at urban form, so looking at Melbourne's continued urban sprawl, or a shift to a more compact urban form, so more aligned with the objectives of Melbourne 2030. Another thing we looked at was changes in residential end use, so such as increased uptake of water efficient appliances, and water service options such as augmentation of water supply with desalination. So the approach applied took a whole of systems view that focused on interconnections and interdependence between different parts of the urban system. This allowed us to explore how change in one part of the urban system may impact on other areas. So for example, how a change to a more compact urban form may impact on water demand and the viability of different supply options. So the advantage of this approach is that we can start to explore the influence of different policy levers and understand where impact can be realised. So for example, in this slide here, I've just got a small diagram at the bottom which shows the magnitude of water savings that could potentially be realised through the urban development decision cycle. So it shows the greatest opportunity to initiate water savings in a new dwelling occurs at the design and building stage. And rushing straight through to some of the key, it's just a snapshot of some of the findings and recommendations from this project. So the results of the scenario analysis, that's quick, I'm trying to speak quickly too. So a shift to a compact urban form could potentially save 100 gigalitres a year. And so that's moving away from things, so it's essentially driven by a projected decrease in garden irrigation, and that demand management options and increased uptake of solar hot water systems can have significant impacts on water demand and also energy requirements. So just quickly, some of the key recommendations. It's important to keep developing our understanding of the energy demands through the urban water cycle, both from the supply side but also from the demand or the consumer side. And secondly, that this type of analysis, we believe, can have some value in developing regional plans and strategies and answering questions such as how does urban design impact on the water system and associated energy demand and greenhouse gas emissions. So if anyone's got some more interest, the full report's available on the CSIRO website. And that's it, and I hope that made some sense in the 3 minutes. Thanks.